The universe is vast, and every now and then, it sends us a postcard. A cosmic messenger from another star system, hurtling through the dark void for eons before gracing us with its presence. We've had a few such visitors, but none quite as enigmatic as the one we've designated 3I Atlas. This object, only the third interstellar visitor ever confirmed, didn't just fly by, it performed. It put on a show that left astronomers scratching their heads and rewriting what they thought they knew about objects from other star systems. Its behavior was so peculiar, so utterly strange, that it defied easy explanation. Was it a comet unlike any we've ever seen? An asteroid with properties that challenge our understanding of planetary formation? Or could it be something more deliberate? The questions surrounding 3I Atlas are profound, touching on the very nature of what might be lurking in the interstellar medium. Today we're going to embark on a journey of cosmic discovery. When we think of objects moving through our solar system, we have a certain expectation. Most comets and asteroids orbit the sun on a relatively flat plane, the ecliptic, much like planets do. They are part of the family, born from the same protoplanetary disk that formed Earth and its siblings. They follow predictable elliptical paths, gravitationally bound to our star. They are, in essence, locals. But 3I/Atlas was no local. It was a tourist from a galaxy far, far away, or at least from another star system. Its trajectory was the first major clue that this was something special. Instead, it plunged into our solar system from above, at a steep, highly inclined angle. This path was hyperbolic, meaning it wasn't a closed loop, it was a one-way ticket. So, what is this thing made of? A simple question with a profoundly complicated and as yet unanswered response. When we observe an object in space, we analyze the light it reflects using a technique called spectroscopy. This process breaks the light down into its constituent colors, a rainbow with dark lines. These lines are like a barcode, revealing the chemical elements and compounds present on the object's surface. For most comets, we see the signatures of water, ice, carbon dioxide, dust, other familiar volatiles. But when astronomers pointed their spectrographs at 3I/Atlas, the results were underwhelming. And in science, sometimes the lack of a signal is the most telling signal of all. The light reflected from 3I/Atlas was mostly featureless. It was a cosmic enigma wrapped in a plain brown wrapper. Imagine you're watching a distant streetlight on a foggy night. It's a faint, steady glow. Suddenly, in the span of just a few days it flares up, as bright as a searchlight, blindingly intense, before fading again. That's essentially what 3I/Atlas did. When it was first detected, it was just another faint speck of light, interesting only because of its interstellar trajectory. But then, something extraordinary happened. It began to brighten. By a factor of nearly 100, this rapid, dramatic increase sent a jolt through the astronomical community. What could cause such a change? For a typical comet, brightening is expected as it gets closer to the sun. Less a gentle sunrise, more a sudden explosion. Several theories were proposed. One idea: massive structural failure. This violent brightening turned 3I/Atlas from a curiosity into a headline-grabbing mystery. How do you figure out the shape of something you can't even see? I mean, we're talking about an object millions of miles away, smaller than a city, visible only as a single point of light. The answer actually lies in how it twinkles, not atmospheric twinkling. This is caused by the object's own rotation. An irregularly shaped object tumbles through space and its presented surface area changes. Long, flat side facing us, it reflects more light and appears brighter. Narrow end facing us, it reflects less light and appears dimmer. By measuring these periodic brightness changes, we create a light curve. The light curve's shape gives clues about shape and rotation. Astronomers found extreme brightness variation in 3I/Atlas light curve. Data pointed to something highly elongated, maybe pancake flat. One dimension was many times larger than the others. This is weird. Very weird. Isaac Newton gave us the laws of motion and universal gravitation. Its path is a dance choreographed by the gravitational pull of every other massive object around it, mainly our sun. We can actually calculate these gravitational effects with incredible precision. So when an object deviates from this gravitationally prescribed path, we have to sit up and take notice. There must be another force at play. 3I Atlas exhibited just such a deviation. It was accelerating, but not in a way that gravity could explain. It was experiencing what scientists call a non-gravitational acceleration, a gentle but persistent push. As a comet nears the sun, ice on its surface turns to gas, jetting out into space. This outgassing acts like a tiny rocket engine, but As we've already discussed, astronomers couldn't detect any. This is one of the central paradoxes of 3I Atlas. What could be providing the push? What makes a comet a comet? It's that beautiful ethereal glow, the coma, and the long sweeping tail that can stretch for millions of miles across the sky. These features are really the hallmark of a cometary visitor. They're formed when a comet, basically a dirty snowball of ice and rock, approaches the sun. The sun's warmth causes the ices to sublimate, turn directly from solid to gas, and this gas carries dust particles with it, forming a vast temporary atmosphere around the nucleus. Now let's look at 3I/Atlas. By all accounts, based on its behavior, it should have been surrounded by a massive, glorious coma. But when the Hubble Space Telescope and other powerful observatories turned their gaze upon it, they saw nothing. This is a major contradiction. The case of the missing coma is a clue that points away from a simple water-ice comet and towards something far more unusual. When you have eliminated all which is impossible, then whatever remains, however improbable, must be the truth. That's the famous line from Sherlock Holmes. And in the face of so many contradictions, a strange trajectory and unknown composition, non-gravitational acceleration with no coma, some scientists began to consider the improbable. Could it be artificial? An artifact of an extraterrestrial intelligence? This is, of course, an extraordinary claim, and it requires extraordinary evidence. In particular, the non-gravitational acceleration combined with the lack of outgassing is consistent with the behavior of a solar sail. A solar sail is a hypothetical, for us anyway, method of propulsion that uses a large, thin reflective membrane to catch the pressure from starlight. The object would literally be sailing on the sunlight, pushed along its path by the photons streaming from our sun. Now, we must be intellectually rigorous here. This is speculation. It remains a tantalizing, if highly unlikely, possibility on the table, a testament to just how strange this object's behavior truly was. We've talked about how the light curve of 3I Atlas suggested a very strange, elongated shape. But the light curve told us something else, something equally bizarre about its motion. It wasn't just spinning smoothly like a well-thrown football, it was tumbling. Its rotation was chaotic and complex. It seemed to be wobbling and spinning on multiple axes simultaneously, like a badly thrown book flipping end over end. This state is known as tumbling, or non-principal axis rotation. While not unheard of, it's a state that usually doesn't last long. Over cosmic timescales, the internal stresses and energy dissipation within a rotating object tend to damp out this wobble, causing it to settle into a more stable, energy-efficient spin around its shortest axis. For an object to be in a tumbling state, it likely means something has recently happened to it to set it off kilter. The recoil could have been powerful enough to change its rotation state, setting it into this wild, multi-axis spin. It wasn't just a visitor, it was a dizzy, tumbling visitor, making it that much harder for us to get a clear picture of what we were looking at before it vanished back into the darkness. The universe rarely gives us second chances. For all the mysteries 3I/Atlas presented, the most frustrating aspect was the sheer brevity of its appearance. Because of its incredible speed and hyperbolic trajectory, its journey through the inner solar system was remarkably short. It was like a rare bird that flies through your backyard for just a few moments. You scramble for your binoculars, but by the time you have them focused, it's already gone. The entire window of opportunity was only a matter of months. This is a blink of an eye, in astronomical terms, and then it receded back into the interstellar night, probably forever. This fleeting visit put immense pressure on astronomers around the world. It was a race against time to gather as much data as possible. They had to coordinate observations. Each choice meant sacrificing another type of data. No second pass. They are one-time events. Before the key piece, the object itself, disappeared from view, leaving us with a tantalizing and incomplete picture. The strangest thing about 3I Atlas, the number one secret on our list, is perhaps the most profound. All the things we don't know. The ultimate mystery is the incompleteness of the data itself. Despite a heroic effort by the global astronomical community, our observations were limited by, think about the fundamental questions. We don't know its precise composition, which is a clue, but it's a negative clue. It tells us what it isn't, but not what it is. We don't have a direct image of its shape. It's inferred from a light curve, which could have multiple interpretations. A cluster of fragments? We are left with a set of competing hypotheses, each as exotic as the next. This lack of data is not a failure of science. It is the very frontier of it. The legacy of 3I Atlas is the burning desire to be ready for the next visitor, so that next time, we can answer the questions this enigmatic traveler left in its wake. And so 3I Atlas continues its lonely journey back into the vast, cold expanse between the stars, leaving us with more questions than answers. It was a fleeting glimpse into the sheer diversity of what the cosmos can produce, a cosmic riddle that challenges our assumptions at every turn. And shape, this object is a testament to the fact that the universe is far more complex and surprising than we can possibly imagine. Thank you for joining me on this deep dive into one of the most compelling mysteries in modern astronomy. The story of 3I Atlas is far from over, and it serves as a powerful reminder that we need to keep looking up. Share your thoughts, your theories, and your cosmic speculations in the comments section below. Because in the quest to understand the universe, every voice matters. Until next time, keep your mind open and never stop questioning.